Let's know the algorithm in solving a linear system with 3 equations and having 2 variables. Say we have this linear system and we want to solve for the solution. That is, we want to know the values of the variables x and y that will satisfy all of these equations. Let's start with labeling these equations. Say this would be equation 1, 2, and 3. If you have this case, that is, you have 3 equations but having just 2 variables, you may just pick up 2 equations from 3 equations and get the solution. We have a separate video that discusses the algorithm and solving solution of 2 equations. Just click that I icon at the upper right corner of your screen to be redirected to that video. If you want a refresher about operations on integers, or like how come we have a positive 1 from having negative 5 plus positive 6, just click that suggested video. For our checking purposes later, let us save the value for our variable x, which is 1 over 23, to our scientific calculator. If you want to know how to save data in your scientific calculator, I have a raw video on how to save this in 3 types of calculator. Yes, that's a raw video, so please bear with me, okay? Let us save as well the value that we obtained for variable y. Once you're done getting the solution for these 2 equations, try to check if this solution would also work for the 3rd equation. If in case it will not be satisfied, then there will be no solution for the 3 equations, because that solution that we got would only work for those 2 equations. Since we already saved the data for our variables x and y, it would be easy for us now to calculate using our sci calculator. That is, with x equals 1 over 23 and y equals 13 over 23, the equation or the 3rd equation 7x plus 3y is actually being satisfied, that would be equal to 2. Thus, a solution exists for these 3 equations or for the given linear system. That would be a point 1/23 and 13/23. For those who prefer to do it manually, we can definitely do it that way. That is, we just have to substitute the values for x and y to this equation and see if this would really be equal to 2. We have a separate video on operations of fractions. Just have the suggested video if you prefer to have a refresher. Graphically, this is how these 3 linear equations with 2 variables would look like. Now let us check if the solution 1/23 and 13/23 would be the solution for these 3 linear equations. That is, this point should be the intersection of these 3 lines. Earlier, we used the elimination method to get the value for variable y. If you prefer to use the substitution method, definitely will arrive at the same answer. Again, we have a suggested video about operations on fractions. Please have that if you're having confusions on this. Let's now have this case. That is, we're having still 3 linear equations, but this time in 3 variables. Let's still have the labels so that we'll be guided. Notice that it would be easier for us to cancel out the variable z if we are to pair up equations 1 and 2, because they have the same numerical coefficient, that is 1, and at the same time they are now in opposite signs. Observe that upon pairing these 2 equations and canceling out the variable z, we still have 2 variables, unlike the case earlier that when we cancel out 1 variable, we are left with just 1 variable. Hence, the algorithm in this case would actually be producing equations 4 and 5 by pairing up 2 different equations so that we'll arrive at a final solution. Yes, you may pair up equations 1 and 2 and have the other pair, which would be 2 and 3. In the same manner, you can actually have the pair 1 and 3 for equation 4 and still have 2 and 3 for equation 5, so as long as you will have different pairings for the equations 4 and 5. In this case, I'd prefer to pair up equations 2 and 3 because they are now in different signs and I just have to multiply 4 to that equation 2. Like that. An important note in producing equations 4 and 5, you need to cancel out the same variables so that you will be left with the same variables, okay? In this case, we are canceling out the variable z and that we are just left with variables x and y. Now observe that pairing up equations 4 and 5 would lead us to the same algorithm in solving solution of 2 linear equations with 2 variables. Again, if you are still confused in this algorithm, it's preferable to watch that suggested video first about getting the solution. Like that. Once you're done getting the values for variables x and y using the equations 4 and 5, you can definitely use either of the 3 linear equations that were given. In this case, I'd prefer to use equation 2 since the last unknown variable, which is z, is already simplified and that we're just using small numbers. Yeah, you may verify there at your end that definitely if you would use equation 1 or equation 3, we'd arrive at the same answer. Let us now save the obtained answers to our scientific calculator so that it will be easier for us to do the checking. the three equations are being satisfied with the obtained answers for variables x, y, and z that we got earlier, definitely this is really the solution for this linear system. This time, let's have the graphical representation of this given problem. Yes, since we're having three variables here, we are actually considering planes. And we are not using Cartesian plane, but we are using XYZ plane. Now, this would be the intersection of these three planes. Is the point 1159s, negative 7859s, and 24559s really the intersection or solution of these three planes?